All right. Now, I mentioned the other day, the type of trinomial that we factored the other day, I told you, I said, look, it's going to be the tougher one, okay? Today, we're still going to look at trinomials, all right? The A value, the leading coefficient, is going to be a 1, which hopefully I'll explain why that's going to be a lot easier today. And we're going to look at a couple of special cases, just so when we see them, we know what to do with them. And once you recognize them, they're really pretty easy, okay? So overall, today should be, I think, a little bit easier. All right, first thing we need to do. Now, you don't necessarily need to write all these down, but what I want you to do, and a big part of this is some recognition on your part, okay? I want you to compare leading coefficients with the expressions on the left compared to the expressions on the right. And when I say leading coefficients, that means that we have to look at the leading terms, and the coefficients are the numbers in front of those terms. What do you notice? What do you notice about the list on the left compared to the list on the right? Leading coefficients. There's numbers on the left, right? And what's the leading coefficient on the right? 1. So if you notice here on the left, every leading coefficient is something larger than 1. That was that A value bigger than 1 that we looked at the other day. Everything we did on Monday had a leading coefficient larger than 1. These, leading coefficient is 1. All right? And that's going to be kind of a big deal. And that's something that you need to kind of look for. Okay? But again, need to be able to recognize it. What the? Oh, jeez Louise. Unlock. There it is. That's what I'm after. Now, if the leading coefficient is 1, you might jot this down. If the leading coefficient is 1, the last term and the last sign is going to give you everything you need. Okay? If the leading coefficient is indeed 1, if all you're seeing up front there is x squared or y squared or s squared or whatever, if the leading coefficient is 1, the last term and the last sign is going to give us everything we need. Okay? And that's kind of a time saver, really. Okay? So I'll give you just a second to jot that down. If the leading coefficient is 1, the last term and the last sign is going to give us everything we need. Okay? All right, everybody good? Okay, so let's check this out. All right? Again, trinomial, x squared minus 2x minus 3. Very similar to what we saw the other day. Okay? Obviously, today we're going to get a leading coefficient of 1 right there. Okay? That leading coefficient is 1. Now, again, we're always going to look for a greatest common factor first. Is there anything common in those 3 terms other than 1? There is not. And especially if I have a leading coefficient of 1, if I have a big number that's a 1, guys, you're not going to do better than a 1. And there's not an x in every term. So there is no greatest common factor. So we're back to our 3 keys. First term, last sign, 2 sets of parentheses. There's those 3 keys. Anytime we're going to factor trinomials, we're going to look at those 3 keys. First term, last sign. Now, the first term. Now, this is real easy. What's the only way you're going to break up a 1x squared? Another 1x squared. X and x. Easy. Okay? Now, remember this outside-inside thing that we talked about the other day? I want you to look at something. Here's why that leading coefficient is pretty nice. If the leading coefficient's 1, that means I've got a 1x and a 1x here, okay? It doesn't matter what I put on the back end of these parentheses. Whatever you put on the back ends is going to be multiplied times 1. And anything times 1 is itself. And that wasn't really the case the other day. But today, that's why this one's easier. If your leading coefficient is 1, the front end of your parentheses is going to have a 1 there. Whatever goes on the back end gets multiplied times 1. It's not going to change. So what we're going to be able to really focus on here, and I kind of alluded to it on the last screen, the last term and the last sign is going to give you everything you need. 3. What's the only way to multiply and get 3? And the last sign is a minus sign. Do 3 and 1 subtract to 2? They do, don't they? Okay. It has to be 3 and 1. The 3 and the 1 will subtract to make a 2, so this is going to work. And notice what your outside is. 1 times 1 is 1. 3 times 1 is 3. You get a 1 here, you get a 3 here. Okay, we knew that was going to happen. The last thing we need to do is just determine, guys, what kind of a 2 is this? It's negative. So who needs to be negative, the 3 or the 1? The 3. X minus 3, x plus 1. Are you dying?
Not necessarily.
Try to hang in there a little bit.
What if you flip the 3 and 1?
If you flip the 3 and the 1, no big deal. Same thing. The 3 has to be negative, though. The 1 has to be positive. It's all about what's inside the parentheses. You have to have an x plus 1. We've got to have an x minus 3. Okay? But guys, with a leading coefficient of 1, what you're going to be able to do is you're going to be able to go right to your last term, and you're going to look for 2 factors of that term that are going to give you that middle term. And it's going to eliminate some of that outside-inside work. Okay? And that's why. If the front end of your parentheses has a 1 there, multiplication by 1 doesn't change a thing. Take a look at the next one. X squared plus 9x plus 20. Leading coefficient of 1. There's your 1x squared. We can immediately, first term, last sign, 2 sets of parentheses. And even better, I'm going to put x and x in there. It's the only way you're going to break up a 1x squared. X and x. How many ways can you multiply and get 20? What are the factors of 20? 4 times 5, 1 times 20. Last sign's a plus sign. We got to add to 9. Are there 2 factors that add to 9? Which ones? 4 and 5. And everything is positive, which makes the signs really easy. X plus 4, x plus 5. If your leading coefficient is 1, you can pretty much just shift your attention to the last term, look for factors that will combine to give you the middle term, depending on what that last sign is now. Do we have to add to get the middle or have to subtract to get the middle? That's the only thing we need to look at. The last term and the last sign will give you everything you need. Okay? That's why today's a little bit easier. There's less to consider. Okay? Let's do another one. X squared minus 9x plus 18. Again, leading coefficient. Guys, you need to look for that. And again, it should be pretty recognizable, I think. But that's one place we need to look immediately is look at that leading coefficient. It's a 1. There's not an x in every term. There is no GCF here. First term, last sign, 2 sets of parentheses. We're going to go ahead and break up the x's, x and x. Simple. Now, last sign's a plus sign. Guys, can you think of a way, what are 2 numbers that multiply to 18 but add to 9? 6 and 3. Two numbers that multiply to 18. Your options for 18 are 1 and 18, 2 and 9, 3 and 6. And by gosh, 3 and 6 adds to 9. The last term and the last sign will give you everything that you need. Now, this was that sign combination right here. If we're going to add to get a negative result, both signs are going to have to be? Both signs are going to have to be? Thank you, negative. That is the most missed sign combination. Guys, if you're going to add, the signs have to be the same, and if you're trying to get a negative result, they both have to be negative. Now, take a look at the next one. What do you notice about the leading coefficient? It's 2. It's not a 1. Now, look at these big numbers. Is there a greatest common factor here? 2. Okay? 2, 18, 28. There is a common 2. Again, we should notice pretty quick that, hey, leading coefficient is not a 1, it's a 2. Maybe an alert here. Hey, I've got a GCF of 2. Let's factor 2 out. Let's divide everything by 2. Divide everything by 2. Here is the resulting trinomial. Now, this resulting trinomial, what's the leading coefficient of this trinomial now? 1. Again, we're back to a very nice situation, okay? We got a leading coefficient of 1 with this trinomial. I'm going to keep my GCF. I'm going to go 2 sets of parentheses, and I'm going to go ahead and break up x squared into x and x. So now, again, I'm back to factoring. Thank you. I'm back to factoring a nice trinomial with a leading coefficient of 1. Fowler? Okay.
So I'm studying. I have to retake my ASVAB.
Okay. All right. First term, last sign. Got it. Now, take a look at your last term here. 14. Is there a way I can multiply to get 14 and then add to 9? What are the two numbers that will do that? 7 and 2. And what kind of a 9 is it? So both signs would have to be? Say again. Negative. There you go. Still look for that greatest common factor now. Okay? Here we had 1. We take the 2 out. Your resulting trinomial has a leading coefficient of 1, which is very nice. X and x. Two numbers that multiply to 14 that add to 9, 7 and 2. Okay? When I used to teach the easier trinomial first, students used to get really used to just looking at the last term, trying to make the middle, and then we would go to the tougher type trinomial, and they would really have trouble with that outside-inside thing. So that's why I kind of flip the order in which I teach it. I really want to try to have you develop a foundation for where all these things do come from, and then we can kind of let up and look at something a little bit easier once we have that understanding, okay? But again, it's all recognition. Okay, so far so good? Beautiful. Okay, all right, let's look at some special case stuff, okay? Here's some special case stuff. Immediately, I think we should notice the difference here. How many terms are we looking at here? Only 2 terms, okay? We've been looking at all these trinomials. So far, we factored a lot of things, okay? Big expressions with a lot of variables. We did 4 terms with factor by grouping. We moved into factoring trinomials, 3-term expressions. Now you look at this, there should be an immediate, whoa, okay? This is a binomial, okay? Now, what's the leading coefficient? 1, okay? So again, there's no GCF here. So you kind of go, wait a minute, okay? This is 2 terms, leading coefficient's 1. I talked about this when we came out of break, okay? two sets of parentheses, okay? X squared is a perfect square. X squared is a perfect square. That means it results from something times itself. X squared is a result of x and x. 64 is a perfect square number. Guys, remember what a perfect square is. A perfect square is a result of something times itself. 2 times 2, 3 times 3, 10 times 10, 12 times 12, 20 times 20. What number times itself gives us 64? 8. So 64 is going to be 8 and 8. There is no middle term in this expression. How do we get the middle term to go away? What makes up the middle term was the outside and the inside together. We covered that the other day. How do I get the outside and the inside term to disappear? Well, they have to be identical and they have to be opposite signs. So we're going to go with a plus 8 and a minus 8. The difference of two perfect squares is characterized by two sets of parentheses that for the most part are identical with the exception of the signs. Okay? X times x is x squared. 8 times negative 8 is negative 64. Positive 8x and negative 8x go away. Okay? So when you recognize that you have the difference of two perfect squares, guys, identical parentheses, opposite signs. You're going to get the same stuff in there, just need one of them to be positive, one of them to be negative. That's how you get the middle term to disappear. Okay? So look at the next one. 4x squared minus 49. 4x squared minus 49. And again, hopefully we are recognizing very quickly that, hey, oh, this is a binomial. This is a two-term expression. And there's a minus sign. Okay? How do you think we're going to break up 4x squared? How do we break up the 4? What number times itself gives me 4? So we're going to go 2x and 2x on the front end. There's my 4x squared. Again, as soon as we recognize we've got probably the difference of two perfect squares here, identical parentheses, how are we breaking up 49? 7 and 7. And the signs? Plus, minus, or minus, plus, however you want to do it. Difference of two perfect squares. And guys, this only works with the difference, okay? If it's a minus sign, it only works with the minus sign. If it's a plus sign, it won't work, okay? Okay? We okay with that? That's why it's kind of a special case. But again, recognition is key here. (10x squared minus 90). Again, hopefully we recognize binomial. Okay? There's a binomial here. 10 and 90, are those perfect square numbers? Or not, are they? I don't have a number times itself that'll give me 10. I don't have a number times itself that'll give me 90. So the first thing we always want to look for anyways at GCF, 10 and 90, what would be the greatest common factor? 10. Good. Guys, take a 10 out of this. Okay, we recognize two terms. Like, oh, is this the difference of two squares? Wait a minute, 10 and 90, those aren't perfect square numbers. Hey, let me look for a GCF here. Hey, there's the greatest common factor of 10. Let's factor out the 10. Take a look at what's left over. X squared minus 9. X squared, perfect. Is 9 a perfect square? Is there a number times itself that will give us 9? There you go. So 9's a perfect square. So we're going to hang on to our GCF, two sets of parentheses, x and x, 3 and 3, plus and a minus. This ends up being the difference of two squares once we factor the 10 out. Okay? So again, always in that mindset of, hey, can I get a GCF out of here? Can I pull something out? Can I make the expression more simple? Does the expression become something that I can factor? In this case, it did. Okay? Everybody okay with that? And guys, remember, and should be something you're familiar with anyway. 4, 9, whoops. There's your first 10 perfect square numbers. Okay, we should be familiar with that list anyway, but those are perfect square numbers. Those are numbers that result from a number times itself. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 36, 49, 64, 81, 100. Okay, so hopefully when we see these types of numbers, maybe we kind of have that thought going, oh, hey, that's a perfect square number, okay? Maybe I can try breaking that number up like this because it's a number times itself, all right? But that's kind of your first 10. And that's a list you don't necessarily have to memorize because you can generate that list very easily, okay? Just by multiplying numbers times themselves. Take a look at this next one now, okay? And I think this is the last example. What do you notice about this one? How many terms? 3 terms. It's a trinomial. Leading coefficient is what? 4. Okay, so we're back to a trinomial. The leading coefficient is not 1, so it's not necessarily that easy type, right? So let's look for greatest common factor. 4, 20, and 25, is there anything common besides a 1? Four is your smallest term, so it can't be larger than 4. 4 goes into 20, but not 25. The other factor of 4 is a 2, and 2 won't go into 25 either. So there's no GCF here, so I can't take anything out. So it's kind of like, okay, what do I do? Well, again, want you to notice something. 4 and 25. If I look at the first term and the last term, and also last sign, are those two numbers on that list? 4 is a perfect square number. 25 is a perfect square number. So here's what I'm going to try. This more or less is just like a problem we did the other day, okay? What makes it a special case is kind of what we're going to get as a result here. But here's what I want you to try to become aware of. Your first term and your last term are perfect square numbers. So here's what I would try first. 2x and 2x for 4. 5 and 5 for 25. Now I'm going to make sure this works. Take a look at your outside. 2 times 5 is 10. 5 times 2 on the inside is 10. Do 10 and 10 add to 20? This works. What kind of a 20 is it? Negative. So if I'm going to add integers to get a negative result, both signs need to be negative. What do you notice about the parentheses? They're the same. They are identical. Okay? These parentheses are identical. Guys, this is a characteristic. This right here is what we call a perfect square trinomial. It's a perfect square trinomial. Perfect square trinomials factor into 2 identical sets of parentheses. So if you get a trinomial kind of like this, you're like going, gosh, these numbers seem kind of tougher to deal with. Look at that first and last term. If those first and last numbers are perfect squares, I'd probably try that right now and go, you know what, this might be a perfect square trinomial. Let's break it up. Okay? Now, I also need to mention, you might see this answer written like this. And remember, we talked about that when we came back from Christmas. We got one of these problems. I said, look, when you get that, we got to break it into 2 and do all the distributions. Well, now we're going backwards. So if you factor a perfect square trinomial, you've got 2 identical sets of parentheses, okay? and you're sitting there taking a test one day, and there's multiple choices, and you're like going, I don't see my answer. They probably have it written like this. They're probably saying, look, that's the same thing as 2x minus 5 to the second power. There's 2 of those. Okay, so just wanted to kind of make note of that. Okay, but that's why that one's a special case. Okay, what do you think? All right. Now, in a little bit of summary here, okay? And I've kind of talked about it today. There needs to be, we've done several different types of factoring as far as types of the expressions we've worked on. There needs to be a certain amount of visual recognition on your part so that you kind of know what to do. And I've got some questions here. Visual recognition. Is there just the greatest common factor? Take a look at that first expression I've got up there. Notice that first expression has got different types of variables in it. Guys, if you're seeing these expressions that have X's and Y's and Z's and A's and B's and C's and whatever, if you're seeing multiple types of variables, there's probably a good chance, one, there's a GCF, and that might be the only thing you're going to do. Okay? That's the first type of factoring that we did to start this unit. We said, look, got to be able to pull a GCF, but we got a lot of expressions like this. Okay? But that's kind of a tip off there. Kind of recognize the clues here. Take a look at the next one. How many terms are in that expression right there? 4. We talked about this. We said, look, typically, a lot of times, a 4-term expression, could there be a GCF? Sure. We're always looking for that first. But typically, a 4-term expression, we were grouping it, right? We said, hey, let's come in here with parentheses, and let's group that off. Okay? So again, recognize the cues. Hey, I'm seeing 4 terms. Hey, you know what? Probably a good chance I may have to group this. So we're going to use the grouping strategy with that one. Then we get in to the next one. How many terms here? 3. Trinomials. Trinomials, leading coefficient larger than 1. This is what we did on Monday. Is there a GCF? No. I need first term, last sign, 2 sets of parentheses. Let's start breaking this up. Let's look at outside, inside, that whole process, okay? 2 sets of parentheses. Next one, again, this is what we did today. Trinomial, right? Oh, I got a trinomial. Hey, leading coefficient's 1. Awesome. All I need to do is look at the last number. 2 sets of parentheses. Guys, what are 2 numbers that multiply to 40 but subtract to 3? How can you multiply and get 40, but also subtract to get a 3? It's not good. Think about numbers that subtract and give you 3, like 7 and 4. That's 28, though. What about 8 and 5? 8 and 5, there's 40. 8 minus 5 is 3, okay? But again, recognition. Trinomials. Trinomials, hey, if you've got a trinomial, there's probably a good chance you're doing 2 sets of parentheses. First term, last sign, 2 sets of parentheses. We're still looking for a greatest common factor. And then we get this last one here. It's a binomial. We look at it and go, okay, this is different. That's a binomial. That's a 2-term expression. Do I have the difference of 2 squares? Okay? These are things that we need to be able to look at, recognize, and then say, this is the strategy I'm going with. Oh, I'm just pulling a GCF. Do I need to group? Do I need just 2 sets of parentheses? Is this a trinomial? Okay?